Okay, AIM, here we go again. The solutions for the graded problems on assignment 44 that I accidentally gave you all 100 on. Number 25. We want to graph f of x equals the log base 2 of x minus 3 plus 1. All right, so our base graph is y equals, the parent graph is y equals the log base 2 of x. So that's a graph that has a base of 2. So our parent points are 1, 0, base 2, comma 1, and reciprocal of base, comma, negative 1. Okay, so when we make our graph, one, two, three, four, 4, 1, 2, 3, 4, 1, 2, 3, 4. And I don't have to go too far left. I know for a fact that we're not going to be going left very much. So I'm going to plot these 3 points as my parent points here in blue. So 1, 0 is a key. That's how they say here in some languages. 2, comma 1 is EC. And 1/2, comma negative 1 would be there. Okay, so that in blue would be the parent points for log base 2 of x, but that's not the graph that we want. We want f of x equals the log base 2 of x minus 3 plus 1. So let's review. This subtracting 3 is going to move the entire graph 3 units to the right, including the vertical asymptote, and this plus 1 is going to move the entire graph up 1 unit. Okay, so I'm going to start with my asymptote this time. Instead of having a vertical asymptote at the the y-axis, we're going to go right 3 units. And we're going to have a new vertical asymptote here at x equals positive 3. And I know that the homework didn't ask you for this, and it wouldn't have been marked wrong if you didn't put it, but it's just a good reminder, so I let it be there, okay? So then we're going to take these 3 points, and we're going to move them one by one, right 3 units, up 1. So 1, 0 is going to go right 1, 2, 3, up 1. And let's plot this graph in, let's just stick with white, because that's what color I left the equation. All right, the 2, 1 point. 2, 1 is going to go right 1, 2, 3, and up 1. So it's going to end up right there. And the third point, 1/2, comma negative 1, when we go right 3, instead of being halfway in between 0 and 1, we're going to stick to halfway in between those integers. So 1, 2, 3, just to the left of that vertical asymptote, or just to the right of that vertical asymptote again, but still up 1. So here it ends up coincidentally just on the x-axis. And then we connect the dots, making sure that we don't cross over the vertical asymptote. So this side does keep going up and up and up, but really slowly. And this side gets closer and closer and closer to that vertical asymptote without touching or crossing it. And then it asks us for domain and range. So domain is left to right. This is my leftmost point. My x values get closer and closer and closer, lefter and lefter and lefter to this x equals 3, but it never quite makes it all the way there. So domain approaches 3, but never equals 3. And then to the right, how far to the right do we go? This curve keeps going righter and righter and righter and righter, all the way to positive infinity. My range is bottom to top. Clearly, these y values are going down to negative infinity. And these y values, less clearly, do keep going up and up and up and up and up, just really super duper slowly, just about as slow as any function we encounter in mathematics. So the range goes negative infinity to positive infinity, or all real numbers. All right, that was number 25. Number 26, we want to find the domain. No, not in green. We need to be anal about these kinds of things, but not consistent for some reason. Sorry, that's my, never mind. Okay, so f of x equals the natural log. Really quick, I was helping somebody in one of my college algebra classes, and this is a really common mistake. The natural log, those are the initials LN, not IN. I don't know if that point has been made before, but it is the natural log of 6 minus 3x, then minus 2. And the key word in that question is, what is the domain? There's all kinds of things that we can do with equations. We sometimes solve them, we sometimes graph them. But if it asks me what is the domain, then all I'm interested in is what x's am I allowed to plug in. And in general, in this class, the only things that we have to worry about are dividing by 0, taking square roots of negative numbers, and we cannot take the log of 0 or negative numbers. So the only thing that matters is what's inside my natural log, what's inside my logarithm. That's my constraint. So the insides, the guts, the argument, Tracy, whatever you want to call it. 6 minus 3x. If that has to be positive, if it can't be 0, and if it can't be negative, mathematically the way we say that is, it's just strictly greater than 0. And then we solve for x like we did once upon a time. So I'm going to, no, let's stick with green. I'm going to subtract that 6 over. When I work with inequalities and I do subtraction, my inequality is going to stay, in this case, greater than. I can subtract all day long. Oh, let's make that a negative 6. There we go. No, I don't like that. There we go. Negative 6. And then, but then, to isolate the x, I'm going to need to divide both sides by negative 3. And when I do that, when I'm solving an inequality and I multiply or divide by a negative number, then that means I've got to reverse my inequality symbol around. Greater than becomes less than, regardless of the or equal to's. But that's only when I multiply or divide by a negative number. All right, so the negative 3's cancel, and I get x on the left, and then negative 6 divided by negative 3 on the right is positive 2. If I were to paint a picture of that, 2 might be here on my number line, and all the numbers that are less than 2 are going to be to the right. But we may not include 2 itself. Did I say to the right? I did. I said it to the right. All the numbers that are less than 2 are to the left. Look at what I drew, not what I said. But they have to be strictly less than 2, which means they can't include 2 itself. So how do I show that every number right up to 2 is included? Like, not just 1, but like 1.5, 1.9, 1.99, 1.99999999999999999999999999. We give it a parenthesis. And so then my domain in interval notation is from negative infinity to the left up to positive 2 on the right. And just really quickly, so this is going to include numbers like 0, negative 11, and so on and so forth. And if I take something like negative 11, and I do try to plug it in and see how it does end up in the domain, because this is a minus 3 times a negative 11, which is going to make it positive 33. And then, so this is 6 plus 33, which is what? 39, but it's the log of a positive number, okay? And that's what matters. The only thing that matters is that when we plug in that x, we end up evaluating the natural log, or whatever the logarithm base is, with the log of a positive number, okay? One more thing I want to point out, you probably already noticed this. What about this minus 2? It's outside the log, it's outside the argument. It really didn't matter. It's just there to distract you. It's the woman in the red dress. There's a good matrix reference for you. All right? Number 27. We want to solve. I love solving. The natural log of x squared minus 4 equals the natural log of 3x. Okay? Don't forget, because this is a logarithmic equation, checking our solutions is a mandatory step. I mean, it can be a mental check, but they do have extraneous solutions. So before I box my answers, I need y'all to make sure that I check my work, okay? So solve, we've got logarithms on the left, logarithms on the right. I don't see any free-floating numbers outside those logs. I don't have like a +1 or a -2 or anything like that. So this is the kind of equation that I call log equals log. I can use the one-to-one property of logarithms that say that if the log of this equals the log of that, the only way that can work is if my insides, my argument, Tracy, if this Tracy equals that Tracy. And I know I keep talking about Tracy, and y'all don't get why, but whatever. I'll explain why I call that Tracy one day if you're lucky. So I'm going to solve x squared minus 4 equals 3x. All right, now I have to recognize what kind of equation is that, so therefore how do I solve it? So this, because of that x squared, is a quadratic equation. We have all those methods for solving quadratic equation, including factoring, completing the square, quadratic formula, so on and so forth. My default is to do factoring. So to do factoring, I need to get standard form. I need to get 0 on one side, and I like to keep my x squared positive, so I'm going to move the 3x over to the left side. And there's no like terms to combine it with, so I'm very, very rudely going to just butt in here in between the x squared and the minus 4. That way stuff ends up in descending form, okay? Now, you guys are champions at factoring, so what I'm going to ask you to do is just pause the video, try factoring it on your own if you haven't already. I'm just going to end up with the reveal. My factors are x minus 4 times x plus 1. Now this still equals 0, and little pet peeve of mine, many of you guys fail to continue to write this equals 0, and I never ever take off points, but I do shave 1 year of life off of you every time you do that. So just be aware, you're gonna have a good grade, but you're gonna die early, okay? So this still equals 0. Then my zero factor theorem says if this times this equals 0, then either this factor x minus 4 equals 0, or this factor x plus 1 equals 0, which I can solve those in my head, either x equals 4 or x equals -1. Are those my solutions? Nope, not yet. I got to check. So let's check 4. And when I check 4, all I'm looking for is when I plug in x equals 4 for this x and for this x, do we end up with positive numbers? Okay? Positive numbers inside the log. So if I take 4 and I plug it in, 4 squared is 16. 16 minus 4, positive 12. We can do that all day long. If I take x equals 4 here, 3 times 4 is also positive 12. What do you know? So x equals 4 checks out. But when I do the same thing for x equals -1, -1 squared is positive 1. Positive 1 minus 4 is -3. Boom, I'm done. No matter what the rest of it says, x equals -1 can't be a solution because we don't take the log of negative numbers. We're not those kinds of magicians. So my one and only solution to this equation was x equals positive 4. And remember, if we're feeling fancy, we can do that solution set notation. Ooh la la. That's going to get you a good letter of recommendation. All right, one more problem, right? Number 28. Here's a lesson for you. Don't borrow money from your Nana. She wants her $5,000 back with interest. After you haven't shown up to a Thanksgiving for 6 years, after receiving your graduation present, she wants you to pay her back $8,500. Assuming Nana is compounding interest continuously. That's the most important word. That means we're using the formula A equals P times E raised to the R times T power. What interest rate is she charging you? Okay, so in these problems, I like to list my variables before I try plugging anything in. So do I know the value of A? Do I know the value of P? E is not a variable, it's a number. Remember, E is approximately 2.71828, blah, 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 blah. Okay, so then do we know the value of R, and then do we know the value of T? Okay, so A is the accumulated balance. That's how much it's worth altogether in the end. How much is she expecting you to pay back? $8,500. Okay, the principal was the starting amount, and we are told that we started with $5,000. Okay, I don't see anything here that says anything about an interest rate other than in the question. It is what interest rate is she charging you? So that's our unknown in this problem. But what about time? Our clue here is that we haven't shown up to Thanksgiving for 6 years. So we're going to use 6 years as our time t. Okay? So let's plug in what we know. A is 8,500 equals, the principal is 5,000 times E, we'll just leave it as it is. R is a mystery, it's a variable, but time is 6 years, so I'm going to say 6 times R. So then we solve for our unknown, which means we've got to recognize what kind of equation is this. Okay, well, here I don't see anything that says log or ln, so it doesn't appear to be a logarithmic equation. Where is my variable? My unknown, my variable r is here, located in the exponent. Everything else is a constant, so this is an exponential equation. Okay, so I'm going to try and solve my exponential equation using the tools that we've been practicing for the past week or so. And here's a case where I need to be careful because I'm going to eventually rewrite this in logarithmic form, but I need it to be the exponential by itself equals a number. And I'm multiplying the base and all that other stuff by this 5,000. So I've got to divide that 5,000 off first. So I'm going to divide the right by 5,000. So I have to divide the left by 5,000. And the 5,000s cancel. And then on the right-hand side, I still have E to the 6R equals this 8,500 divided by 5,000. And I actually, no, here's my calculator, here's my phone. So according to the magic of technology, 8,500 divided by 5,000 is 1.7. All right. So it's really hard to solve for an unknown when it's in the exponent, and that's where logarithms come in handy. So I'm going to rewrite this in logarithmic form. Okay, so in logarithmic form, because I'm working with base e, the log that I need is log base e natural log. So then it's the log base e of, not the exponent, but that thing I keep calling Tracy over here, 1.7. That's going to equal my exponent, 6r. So then last step to solve for r is we need to divide both sides by the 6. And notice this is not 1.7 divided by 6. It's the natural log of 1.7. Okay? So the 6's cancel here on the right. And I do have that r equals the natural log of 1.7. divided by 6. And that's the exact answer, but like nobody knows what that really means. So if I did a ballpark estimation, if I take the natural log of 1.7 first, I get like 0.530628 and stuff. And then when I divide that by 6, I get that this is 0.0884 blah, 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 blah. Okay? And I'm going to just round this off to the nearest tenth of a percent. So this in percent form, move my decimal 2 places to the right. This is about 8.84%. I said a tenth of a percent. Let me stand by that. Yay. 8.8%. Nana, that is robbery. You know what I would do? I wouldn't even talk to Nana. I would just keep doing what you're doing, and she'll be dead soon. All right. Well, that was fun, guys.